Hi, good day again, and welcome to our mathematics class. I've been looking at your work and I realize that some of you are mixing up the terms multiples and factors. For example, if we have 4, we can say 4 is a factor of 12. And why is 4 a factor of 12? 4 is a factor of 12 because 4 can go into 12. But 12 is a multiple of 4. Look at that. See the difference. 4 is a factor of 12, but 12 is a multiple of 4. And the clue I would have given you is m for multiple and m for more. Alright, if we count in 4s, we had 4, 8, 12. 4 can go into 12, so 4 is a factor of 12, but 12 is a multiple of 4. Alright, we would have also used the terms prime numbers. And we said, I want to look at our prime numbers. We said 2 is the only even number that is prime. We have 3, 5, 7, not 9, but 11, 13. Today we would like to focus on these first 4 prime numbers. 2, 3, 5, 7. These are prime numbers because they only have 2 factors, 1 and itself. Alright, so we want to recap because we remember we are working step by step. So for those students who are not looking at the video and are not doing the exercises, you will be left behind. And this is the last straw that God has given you to understand mathematics. So let's look at it. We have been looking at finding factors using the iterative or the listing method. And we said if we want to find the factors of 12, we start with 1. 1 times 12. 2 times 6. 3 times 4. Good. Now look at that. We would say the factors of the factors will be 1, 2, 3, 4, 6, and 12. So here it is. We can look at finding the HCF, or the highest common factor. And to find the HCF, where we have 2 numbers, for example, if we have the numbers 15 and 20, and we want to find the HCF, or the highest common factor, we would find the factors of 15. 1 times 15, not 2, because 15 is an odd number. 3 times 5, not 4. 5 times 3, but we already have 5. So we say the factors of 15 are 1, 3, 5, and 15. And the factors of 20 will be 1 times 20, 2 times 10, not 3, because 3 cannot go to 20 exactly, but 4 times 5. We already have 5, so we stop there. We stop right there. So we say the factors of 20 will be 1, 2, 4, 5, 10, and 20. And then we have to find the common factor. What is common? Oh, what is common here? We have 1, we have 5. 5 is common, and 5 is also the highest common. So the common factor is 5, 1 and 5, but the highest common factor is 5. Alright? This morning, as I would have recapped, I would like us to look at a number, and if we look at the numbers in the factors of in the factors of 15, if we look at the factors, we would see we have 1, 3, 5, and 15. So what we can safely say, we can observe something about these factors. We can observe something about these factors. What we would observe is 3 is a factor of 15, but 3 is also a prime number. 5 is a factor of 15, but 5 is also a prime number. Yeah? So some numbers can be factors of a number, but they are prime numbers. Let's look at the factors of 20. 2, the number 2 is a prime number, but it's a factor of 20. 4 is not a prime number. 5 is a prime number. The number 5 is a factor of 20, but it's also a prime number. So what can we say? We can say that since 2 is a factor and 5 is a factor of 20, they are both factors of 20 and they are both prime numbers, we can go one step further and we can say, we can call them, since they are prime numbers and they are also factors, we can call them prime factors. And we say the prime factors of 20 will be 2 and 5. 2 and 5. So we can say 2 and 5 are the prime factors of 20. Let's try another one. Let's try the number 24. We have 1 times 24. Good. We have 2 times 12, 3 times 8, 4 times 6. Look at these factors: 1, 2, 3, 4, 6, 8, 12, and 24. Look at those factors and tell me, which of those factors are prime numbers? Yes, firstly we will get 2. So we're looking for prime factors. It's a prime number and also a factor. So we're looking at 2, 3. That's it. 2, 3, yes. Because 4 is not prime, 6 is not prime, 8 is not prime, 12 is not prime. The only factors that are here and they are prime numbers would be the numbers 2 and 3. So therefore 2 and 3 are the prime factors of 24. Good. Alright. Now what we can do with our prime factors, we can express a number. We can express a number as a product of its prime factors. Look at this. Remember, we want to get prime numbers only. We want to take a number and express it as a number as a product of its prime factors. So let's use 24 again. I can use 24 and I can use the factor tree method. This is the first method. Look at this. So I have the number 24 and I draw 2 branches and I can just select at random any 2 numbers when multiplied together would give me 24. What times that will give me 24? Good. If you choose 6 times 4, that's good. Alright, but 6 is not a prime number and 4 is not a prime number, so we allow to have branches again. So what do we have? 3 times 2. Look at that. 3 times 2 would give me 6. And we look at the number 4, and since they are not prime, 4 is not a prime number, what times what will give you 4? 2 times 2. Look at that again. We had 24. We drew 2 branches. 6 times 4 will give me 24. But since 6 was not a prime number, we drew 2 branches again and we said 3 times 2 give me 6. 3 is a prime number, 2 is a prime number, so we stop that growth there. We look at 4. 2 times 2 would give me 4, but 2 and 2 are prime numbers. And look at that. You know what I would do? I would take the numbers only at the end of the branch. The end. I cannot use 6 and I cannot use 4, because I would have broken up 6 and 4 into 3 2s are 6, and I would have broken up 4 into 2 2s are 4. So I take my numbers at the end of the branch, starting with the smallest one. So I have a 2 here, a 2 here, and a 2 there. So I put it like this. 2 times 2 times 2. Where did I get these 2 from? Right here. 1, 2, 3. Look at 1, 2, 3. Right? And look, there's a 3 here. I take that 3 and I put it across here. And see what happens. What happens there? Huh? Look at this. 2 times 2 is 4. 4 2s are 8. 8 3s are 24. You know what is this? We would have written the number 24 as a product of its prime factors using the factor tree method. Let's do another question. Alright? Let's look at the number 40. Yeah? If we look at the number 40, we drew our 2 branches, so we have 8 5s are 40. But you would have observed 5 is a prime number. So let's break up 8. 4 2s, 8. Let's break up 4. 2 2s are 4. Good. So we all have prime numbers here to the end of our branches. Remember, we are not going to use 8 because 8 was broken up. And we are not going to use 4 because 4 has broken up, 4 has branches, right? So using our factor tree method, we will say 40 expressed as a product of its prime factors would be 2 times 2, 2 times 2, times this other 2 here, times 5. Only the numbers at the end of your branch, and then work it out and see if you get back 40. Let's see. 2 2s, 4, 4 2s, 8, 8 5s are 40. Good? So what we would have done there, we would have said 40 as a product of its prime factors would be 2 times 2 times 2 times 5. Good? And that is the factor 3 method. Alright? But I can show you another way, I can show you another method how to express a number as a product of its prime factors. Let's use 24 again, alright? Remember, for 24, when we had done this question here, what we had gotten? We would have gotten 2 times 2 times 2 times 3. Yes, we would have gotten 2 times 2 times 2 times 3. So let's try it here. We put 40. Sorry, we put our 24. Write your 24. And look at this. So I'm looking for a prime number that can go into 24. And the first prime number I'm going to think about is the number 2. 2 into 2, 1, and 2 into 4, 2. Yes. 2 into 24 is 12. Can 2 go into 12 again? Yes. 2 into 12, 6. Can 2 go into 6 again? Yes. 3 times. Can 2 go into 3? No. But what can go into 3 exactly? 3. 3 into 3, 1. And I work until I get 1 to the end there. And look what I got. Look what I got, boys and girls. I got 2 times 2 times 2 times 3. Same thing we had up here. 2 times 2 times 2 times 3. So we write it down. 2 times 2 times 2 times 3. So we get 2 2s are 4, 2s are 8, 3s are 24. So we would have expressed 24 as a product of its prime factors. And then let's use 40. What we had gotten for 40 when we used the factor tree method, we would have gotten 2 times 2 times 2 times 5. Let's try it here. Let's try it. 40. And this method, we are dividing by prime numbers. Yes, we are going to divide by prime numbers. So we look at 2 into 40. 2 into 4, 2. And 2 into 0, 0. 2 again, 2 into 2, 1, and 2 into 0, 0. Can 2 go again? Remember, you must know your rules of divisibility to do these. I know that 2 could go into 40 because 40 ends with 0. It's an even number. 2 into 4, 2. 2 into 0, 0. 2 into 2, 1. 2 into 0, 0. 2 into 10, 5. Can 2 go? Can 3 go? No. What's the next prime number? 5. 5 into 5, 1. Good. So what do I have? I have 2 by 2 by 2 by 5. 2 2s, 4. 4 2s, 8. 8 5s are 40. Alright? So what I would do, I will get on an exercise for you all to do, and you have fun working with numbers. And remember, these exercises are geared for you to build number sense, because when you go further into mathematics, you must be able to do these. So you can look at the video several times and make sure you understand. What do you need to understand? You need to understand the difference between a factor and a multiple. 4 is a factor of 12, but 12 is a multiple of 4. And when you go to the bank, they will say, listen, this machine here dispenses multiples of 20. So in other words, you could get $20, $40, $60, $80, or $100. You cannot go to the bank to withdraw $50 from a machine, because 50 is not a multiple of 20. Got that? Yes. So, boys and girls, we would have looked at numbers that are prime numbers, that are also factors of a number. We say they are called prime factors. And to find the prime factors of a number, we say we can use two methods. One, we can use the factor tree method, or we can use the division by prime numbers. And then you state your product. You express the number as a product of its prime factors. Remember, there's a difference when if you are asked, what is the prime factors, or what are the prime factors? You simply list the prime factors. But if you are asked to express a number as a product of its prime factors, then you can use the factor tree method, or the repeated division by prime, and you arrive with your response. So, until next day, enjoy.